Hello students, so today we are going to start some basic concepts of chemistry, which is the important chapter for all the other chemistry chapters, because in this chapter itself we are going to discuss all the basics required for all other chemistry chapters. So the name itself is saying basic concepts, so the main important topics are mole concept and concentration terms. Before understanding that topics, let us see the basics required for all of this. So if you see, most of the times we are hearing these terms called atomic mass, gram atomic mass, and then atomic weight. So all of them are somewhat, we are getting some idea that all of them are somewhat related to weights or some amount of the atoms. But why there are all these three different words given for this? Weights only, like amounts only. So by the end of this class, you will be understanding the differences between these three terminology. So we basically believe that all these three words are same, but no, there is a differences between all these three terminology. We will see one by one. So first, atomic weight. So what is the first one? Atomic weight. So what is this atomic weight? Atomic weight is nothing but weight of an atom. What is atomic weight? Weight of an atom. So basically in the earlier days we didn't have this much advanced technology and all of that. During that time it was just given the numbers. So whenever we mention weights, it has no units. It has no units. So that is what atomic weight. So we don't need to focus much in the atomic weight or whenever we say molecular weight something. But we have to focus on these two words. What is that? Atomic mass and gram atomic mass. So first we will be discussing how this atomic mass came, and then we will be going into the gram atomic mass. So the name itself is saying, right, what is that? Atomic mass. What is atomic mass? It is a simpler definition. You don't take much stress on that. Atomic mass is nothing but, so what is atomic mass? Atomic mass is nothing but, it is mass of one atom. We have to specify this. What is atomic mass? Mass of one atom, because depending on how many atoms we are taking, the terms will be varying. If we are especially taking one atom mass, that is called atomic mass. After discussing molar mass also, you will get more clarity on this. So atomic mass is mass of an atom, and units will be discussing. So now we simply want to calculate how much is there inside an atom, right? So before going to that, let me tell you an example. Imagine we have a container. Imagine we have 1 kg sugar in it, 1 kg sugar, and 1 kg salt we have in this container. So now if I ask you how much is the mass of this container, you will simply say 2 kgs, right? How? First you will say what is there? What is there? Sugar is there, salt is there. Then we will see how much is there. Then we will see how much is there. First we will see what, and then how much, right? So after that we have added all of those. 1 kg plus 1 kg, we got 2 kgs. It is as simple as that. Similarly, if I ask you what is atomic mass, it is mass of an atom. First, what we have to know? What is there inside an atom? So already we know that atom consists of, what is atom consist of? Protons and neutrons as well as electrons. An atom consists of protons, neutrons and electrons. So now when we are looking into these three, we have to know how much is each their quantities. So that's what we will be learning in structure of atom. Mass of one proton. It was calculated by Thomson by this cathode ray tube experiment and all of that, which we will be discussing slowly in the structure of atom chapter. So mass of one proton is 1.672 into 10 power minus 27 kg, or we can convert it into grams also. 1 kg is 10 power 3 grams. So it will become 1.672 into 10 power minus 24 grams. This is what, Nana? This is mass of one proton. Similarly, mass of neutron is, it is slightly more value than mass of a proton. We usually take masses of proton and neutron equal only, but it is not exactly equal. There is a slight difference between proton and neutron mass. This is the difference. The same value minus 27 kg, or we can even take 1.6749 into 10 power minus 24 grams. Because these values also we should learn, because in the structure of atom chapter they can ask you to arrange the increasing order or decreasing order of masses, charges, all of this. And then mass of electron. Mass of electron is 9.1 into 10 power minus 31 kg or 9.1 into 10 power minus 28 grams. Okay, we got to know what is there inside an atom and then how much is there inside an atom. Like this example. Now what do we have to do? We have to add them. How do we add them? If we are adding all these values, every atom consists of protons, neutrons, electrons. If these values are already fixed, every atom should get the same atomic masses, right? But is that correct? No. We have learned in previous classes that hydrogen atomic mass is 1 and then helium it is 4 and then lithium it is 7. How it is differ? Because protons, neutrons, electrons mass is fixed. This is for one proton, one neutron and one electron. But in each individual atom, the number of protons, neutrons and electrons varies. That is the reason we will get different answers for different atoms. Now let me take an example, which is I want to find carbon atomic mass. So we want to find carbon atomic mass. So we all know that what is carbon atomic number? 6. Carbon mass number is 12. So if I calculate the protons, neutrons and electrons, so how many protons are there, Nana, here? Atomic number refers to protons. So it contains 6 protons and 6 neutrons, because A minus Z is number of neutrons, and then 6 electrons. Now I got to know how much are there. So if I calculate mass of carbon, what it will become? 6 into mass of proton, because we should not just take mass of one proton, because there are 6. And then we will add 6 into mass of neutron, and also we will add 6 into mass of electron. This is actually should be done. But what I'll say is, we have to ignore this mass of electron while calculating the atomic mass. Can you guess why? Because our answer is already in front of you if you have checking these values. So already 10 power minus 27 or 10 power minus 24 values are very much smaller values, right? To that very much smaller values, if you are adding this electron mass, which is 10 power minus 28, which is even more lesser value, yes or no? So to 10 power minus 24, if you are adding 10 power minus 28, it's not that huge difference will be observed. If you see, like 100 is there, 200 I am adding 0.000001 something. Is there any difference? Yes, difference will be there, but not huge. Huge difference won't be there. That is the reason while we are calculating mass of an atom, we will only consider protons and neutrons. That's what in structure of atom we will understand. Mass of an atom only depends on protons and neutrons, but not electrons. Why? What is the reason? Because it is very less value. How much is its value, Nana? It is 9.1 into 10 power minus 31 kgs. So now let us substitute. Mass of carbon is equal to 6 into 1.672 into 10 power minus 20. Let us take it in grams, 24 grams, plus 6 into, now what I'll do is, I'll take mass of neutron also same as proton, because they are almost same, right? For my convenience, I'll take it as 6.672 minus 24 grams. Now 6, if you take this value common, we'll get 6 plus 6. How much, Ra? 12 into 1.672 into 10 power minus 24 grams. Now you are getting this doubt. Ma'am, I have never seen this much bigger value for mass of an atom. I simply know 12, right? So that's what this all bigger value corresponds to AMU. So now what we can write is mass of carbon is equal to, what is left, Nana? 12 AMU. What is AMU? That is important now. So AMU is a unit of atomic mass. Name only saying AMU. What is AMU? Atomic mass unit. What is AMU stands for? Atomic mass unit. What is its value? They can ask you like the questions on AMU, like one AMU stands for, and they can give you 4 options in which they can tell what is atomic mass unit. and then its value is 1.672 into 10 power minus 24 grams. That means technically mass of proton is equal to an AMU value. And also we can also say this AMU in terms of carbon. Why only carbon? I'll explain you in the next topic. So here if this 12 goes this side, now 1 AMU will become 1/12 of mass of carbon. That also we can say. So 1 AMU is also equal to 1/12 part of mass of C12 especially. We'll talk why only carbon, why can't we take other elements, I'll explain you. C12 atom. So these are the all values that are corresponding to AMU. Okay. So now this AMU has other names, like we can use the other units for atomic mass, which are, first one is AMU, of course this is the most used one, or we can even use U. We can even use U. What is U, Nana? U is nothing but unified mass. What is U? Unified mass. So this has other names as AMU, Dalton, Boston, Avogadro, something like that. But all of that just for your understanding purpose only. The one which we use more is AMU or U. Okay. So now what is atomic mass? Did you get clarity now? Atomic mass is nothing but mass of one atom. You have to be very clear in it. And what are the units? Units are in AMU. What is the AMU value? This much is the AMU value. This is what atomic mass. Now, before going to gram atomic mass, let me also explain you molecular mass. Molecular mass. Can you tell me, if atomic mass is mass of one atom, what could be molecular mass? Isn't it simply mass of one molecule? It is mass of one molecule. Units are same, Nana. AMU. What is molecular mass? Mass of one molecule. Can we also write it as, it is the, because we don't know each individual molecular mass, but we have to learn at least 30 elements and their atomic masses. I will give you the list of 1 to 30 or 1 to 20, whichever that is important. So we can even say sum of atomic masses of all atoms present in the molecule. This is what? Molecular mass. So before starting molecular mass, let me give you the elements which are important, which will be useful in the first chapter itself. Because by that chapters going on in the periodic table itself, you will be learning lot of the elements and their atomic masses. But for now, it is very important to learn at least 30 elements and their masses. I will write down the symbols directly. So hydrogen, here I will write atomic mass. As I am saying atomic mass means obviously the units are in AMU only, should not think otherwise. So hydrogen atomic masses, I am not writing what is that units again. I am not writing the units again. Let me simply write 1. And then helium, how much? 4. Lithium, 7. Beryllium, 9. Boron, actually it is 11. We'll take it as 10 point. It is 10.8, but we'll take it as 11. Actually, whatever all these values also, these are not exactly whole numbers. They are like something 4.008, something like that is there. But we don't need to take that much accurate value, just these values are enough. And then carbon, 12, nitrogen, 14, oxygen, 16, fluorine, 19, and then neon, 20, sodium, 23. We'll learn why it is named as why it is given as Na, because of its Latin name. That's what we will discuss in periodic table. And then magnesium, 24, aluminium, 27, and then silicon, 28, phosphorus, 31, and then chlorine, 35.5, and then we have argon, 40, potassium, 39, and then calcium, 40. These are the 1 to 20 elements. Along with that, some more other elements are there which you have to learn. Like iron, atomic number is 26, mass number is 56. So you should not think like only till now whatever you have learnt is atomic mass is just its atomic number into 2 for even numbers and in plus 1 for odd numbers, but it's not, the trend is not for all elements. It works only maximum till 20 elements. After that they have their individual masses. So iron, it is this, and then we have copper, which is atomic number 29, mass number is 63.5, and then bromine, it will be 80, its atomic number is 35, and then we have silver 47 and atomic mass number is 108. So for first chapter, if there is any atomic masses required, they can give you those values in the what we can say question. But for at the end of the exam, like at the ending of the main exam, it might not be given. You should not be surprised that why these values are not given. You have to learn these values at any time. So these are the values, please take a note down. Okay, fine. So these are what atomic masses of individual atoms. Now I want to calculate molecular mass. What did I say, Nana? What is molecular mass? It is simply mass of one molecule or sum of atomic masses of all atoms present in it. So let us take one example, which is CH4. You have to learn the names also. And by the way, for your information, you won't be asked to calculate the molecular mass separately as a question. You will be asked to find moles or some other things. In that, all these things, we have to find their molar masses, I mean molecular masses, then only we can do. That's what it is very important. So now, you have to check what atoms are present in it. So what atoms are present inside this molecule? There is 1 carbon and then 4 hydrogen. Just now we have learned what is the atomic mass of 1 carbon atom, Nana? 12 AMU. So that's what we have to take it as 1 into 12 plus. For 1 hydrogen it is 1 AMU. There are how many hydrogen atoms? It is 4. You have to take the subscript and multiply with their atomic masses, because whatever I have given earlier, they are for one single atoms, but here we have 4. That's what will multiply with 4. Why we did not multiply with anything here? Because so there is only 1 carbon atom. How much in total, Nana? 12 plus 4, it will be 16 what? 16 AMU. As simple as that. Okay. And let me tell you one more example. H2SO4. H2SO4. I think I forgot to give sulfur atomic mass. It is 32 AMU. Atomic number is 16. Okay. Now, what is the molecular mass of sulfuric acid? Check how many hydrogen atoms are there? 2. In this molecule, there are 3 types of molecules present. What are those? Hydrogen, sulfur and oxygen. Now, we already learned hydrogen atomic mass, sulfur atomic mass and oxygen atomic mass. Can you tell me how many hydrogen atoms are there? 2. What is atomic mass of hydrogen? 1. So 2 into 1 plus sulfur, it is 32. Only 1 sulfurs are there. That's what 1 into 32. And oxygen, it is 16. There are 4 oxygens. That's what 4 into 16. So 2 plus 32, 34. 34 into 16, how much, Nana? 64. 34 plus 64, it is 98 AMU. Very important values. That's what, you don't need to by heart these molecular masses. If you just learn those atomic masses, easily you can calculate the molecular masses, right? This name is sulfuric acid. Similarly, you please practice these questions, which is HCl and then H3PO4 and then HNO3. Next C6H12O6, C12H22O11, and then we have CO2 and C2H6 and then C6H6. These are some important molecules which we might get. So HCl is called hydrochloric acid, phosphoric acid, nitric acid, glucose or fructose, sucrose, carbon dioxide, ethane and then benzene. So these are the compounds. You please try these values and you can get all their values. I have already given atomic masses, right? Based on that you can try these questions. And then so far what we have completed? We have completed atomic mass and molecular mass. Now we have to start what is gram atomic mass, because in the beginning of the class I told you there are three confusing terms: atomic weight, atomic mass, gram atomic mass. Already we have completed what is atomic weight. It is just simply weight, it doesn't have any units. What is atomic mass? Just now we completed mass of one atom. What are the units, Nana? AMU. Then what else is left? Gram atomic mass. So before going to start gram atomic mass, we have to know few things. What is that? Mole concept. This is the most important topic of this chapter. Not just this chapter, remaining all chapters also this will be very useful. Everywhere, without moles or without mole concept, there is no chemistry chapter present in the syllabus. Okay. So now what is mole? So have you ever think what is mole? So whenever I ask this question, so you will be saying it is Avogadro's number 6.023 into 10 power 23. That is the value. I am asking what is mole? What is mole? So let us consider one simple example in real life which we use. In real life, do you remember we use dozens? When we go to market, we use like to buy eggs or bananas. We use dozen. What is one dozen means? How many number? 12 numbers of bananas or something. Like one dozen means 12 in number. And we also use one pair. What is one pair represents? Two numbers, right? So why are we using these terminology for our simplification? Because let's say if it is 12, it's fine. But if I needed something like around 2400 eggs, let's say, I can't count or I can't keep that value as a big number because 2400 feels bigger for me. What I'll do? I'll convert into dozens. Now can I simply say 200 dozens? Now instead of saying 2400, we can simply say 200. Is it this 200 feels little easier and simpler for us? Right. That's what. To make this representations, right? We gave like to make the bigger values into smaller values or smaller values into bigger values, we have converted this representation. This is in real life. Similarly, in chemistry, we have this mole. This mole is nothing but it is just a chemical representation. What is mole, Nana? It is just a chemical representation used for amount of substance. What is mole? It is a chemical representation used for amount of substance. Ma'am, you just told that for amounts and all we have atomic mass, molecular mass, all of that, right? Again, why this mole? That's what we will be learning, all of those one by one. So what is that? It's a chemical representation. Remember, whenever I ask you what is mole, you have to say it is a chemical representation. Now this one mole have different values and different terms. Whatever Avogadro's number is there, that is one of the value for one mole, but it is not just one and only value for one mole. So let me tell you. So one mole has three values in three different terms. The first one is in terms of mass. One mole of substance in terms of mass is nothing but molar mass. We will talk about this topic only after this one. Okay, what is one? These three are very important, Nana, to do all the mole concept related questions. You have to be very careful in this. One mole value in terms of mass is what? Molar mass. Now, one mole value in terms of particles. What do you mean by particles? Particles is nothing but it can be atoms, it can be molecules, it can be ions. Okay, or it can be electrons, protons, neutrons also. Anything we can say. Particles means anything. So it is only called Avogadro's number. You should not directly say one mole is always Avogadro's number. In terms of particles, it is Avogadro's number, which is this symbol, Na. Both should be capital. What is its value? This is nothing but 6.023 into 10 power 23. This is Avogadro's number. This is in terms of particle. So we have learned one mole value in terms of mass, which is nothing but molar mass. One mole value in terms of particles, which is nothing but Avogadro's number. and then 1 mole value in terms of volume, but it must be mentioned at STP. What is STP? STP is nothing but standard temperature and pressure. STP is nothing but standard temperature and pressure. How much is its values? I mean, either they'll mention in the questions as STP at the ending of the question, or they'll mention 273 Kelvin, 1 atmosphere or 1 bar pressure. Anything will be mentioned. Without that specification of STP or this specific temperatures and pressures, we should not use this value, which is 1 mole value is 22.4 liters. This is given by Avogadro, which we'll be learning later. So basically, these two does not have any conditions. We can take 1 mole value of any substance in terms of mass is its molar mass at any temperatures and any pressure. Similarly, particles also, it is Avogadro's number at any condition, but volume should be mentioned at STP. Please take a note down. This is very important because based on these three values only we will be discussing whole mole concept. Now our focus should be on this molar mass. Is it clear? Yes. Let us see molar mass. What is molar mass? Remember, you can see something here, molar. Isn't it property of mole? Yes. Molar mass is nothing but it is mass of 1 mole of substance, mass of 1 mole of substance in grams. Mass of 1 mole of substance in grams is nothing but molar mass. So now if you see this thing here, when we are looking into this, already we have seen atomic mass, molecular mass, gram atomic mass, all of that, right? That's what, if you keep atom in the substance place, like if you are specifying for atoms, that is called gram atomic mass. That is only represented as GAM also. Either it can be called as GAM or gram atomic mass. If I specify for molecules, that is called as gram molecular mass. That is called as gram molecular mass, GMM. So, what is molar mass, Nana? It is mass of 1 mole. You have to be specify here because in the atomic mass I told you it is mass of just 1 atom. Okay, here how many atoms I'm saying? 1 mole. That's what, whenever it is 1 gram atomic mass, we can write it as mass of 1 mole of atoms in grams. What is gram molecular mass? It is mass of 1 mole of molecules in grams. Okay, now you take the atomic mass definition and molecular mass definition to here. What did I say, said Nana? Atomic mass definition, mass of 1 atom. Okay, gram atomic mass, what I am saying? Mass of 1 mole of atoms. That's the first difference. And then second difference, atomic mass units are AMU there and gram atomic mass units are grams. Okay, next. Similarly, molecular mass units, what is molecular mass definition first? Mass of 1 molecule. Here how many molecules I am saying? Mass of 1 mole of molecules, and there also the units are AMU and here also units are grams. These are the main difference. But how, ma'am, if it is 1 atom or 1 mole of atoms, how does it differs? Means 1 atom means just let us consider atoms as a balls here. 1 atom is just imagine 1 ball on one side, and 1 mole of atoms means how many number, Nana? Avogadro's number 6.023 into 10 power 23. Did I give you that value? Yeah. So 6.023 into 10 power 23 number of atoms. That means that many balls you have to imagine here. You just, for imagination only we can't do, like 1 ball on one side and these means 6023 and 20 zeros after that. That many balls on other side. It is difficult, right? That's what, both the values are not same. I mean, number it is same, Nana, but units are different. If you observe the thing clearly here, the units, which in one way it is AMUs and the other way it is grams, right? So, but value is same. That's what in physics and chemistry especially, units are very important. Without units, it's just maths only. Okay, so number will be same. So, this is what molar mass. So, let me calculate GAM of carbon only. GAM of carbon only. Already I know carbon atomic mass, which is for one atom. GAM, if I specify, for how many atoms I have to calculate? Avogadro number of atoms I have to calculate. It is a simple basic maths. This calculation, whichever I am going to explain, that is not required for you to learn, but it is the very important understanding. If you get these points, now the remaining mole concept will become very clear for you. So let me take one example. I went to a shop and there one pen is costing me around let us say 5 rupees. Okay, now I want to take 10 pens. How much it will be? 50 rupees. Yes or no? What we have done, Ra? We have multiplied the amount of one pen with the number of pens we needed. Yes or no? Same thing we will use here. For one carbon atom, mass I know already. How much is? 12 AMU. What I am saying is, take this AMU value in grams. How much, Nana? 1.672 into 10 power minus 24 grams. This is what? One carbon atom mass, which is like one pen cost. Now, if I have to calculate GAM, for how many atoms I have to calculate? 1 mole. What is 1 mole value? 6.023 into 10 power 23 atoms we have to calculate. For that, how much it will be? What do we have to do? Just we have to cross multiplication or multiply this with this. That's what, whenever it comes to GAM of carbon atom only, it will be 6.023 into 10 power 23. Are you understanding why I am multiplying with Avogadro's number? Because that Avogadro's number is the number of atoms I want to calculate mass, like this number of pens, and each individual mass is 12 into 1.672 into 10 power minus 24 grams. Here comes the magic. If you multiply the 6.023 into 1.672, you will get approximately 10.05 something. So that So take this 12 as it is. That we don't do anything, and 6.023 into 1.672 if you do, we'll get exactly, approximately 10.05 something. Let us take it as 10. And what else is left? 10 power 23 and 10 power minus 23. Isn't it 10 power minus 1? Yes. What are the units left, Nana? Here G. Take that G as it is. 10 into 10 power minus 1. 1. What is left finally? 12 grams. That is the magic here. Like, we didn't do anything. We did not just, I'm not saying that GAM and AM are same, like atomic mass and gram atomic masses are same, just change the units. No, it's not like changing the units directly. It is that atomic mass is for one atom, that's what units are in AMU. Or in grams, this much it will be, very smaller value. If it is for gram atomic mass, it is for 1 mole, that's what we will get 12 grams. If you see here, for atomic mass or gram atomic mass, the numbers it is same, 12, that will be same. Units are AMU and grams here. Of course, you will be remembering it as same, units different. But it is not just units different, it is also about the number of atoms we are taking. That's what the main difference. So this is about what we can say, gram atomic mass. So let me tell you about like how to distinguish now. Atomic weight, atomic mass and gram atomic mass. What is atomic weight? Atomic weight is nothing but weight of one atom. What is atomic mass? Mass of one atom. What is gram atomic mass, Nana? It is mass of 1 mole of atoms. This is the first difference. Next, units. Units is the second difference. When it comes to units, it does not have any units. It have units AMU or U. What is AMU? Atomic mass unit. And this has units grams. And now if I take examples like carbon. If I ask you atomic weight, you should say just 12. Okay, that's it. If I ask you atomic mass, you should say 12 AMU. And if I ask you gram atomic mass, You should say 12 grams. That's it. It is as simple as that. So whenever the numbers are same, of course, again as I told you, but without numbers, chemistry is without units, chemistry is just maths. That's what you have to specify the units and all. Now let me take another example, oxygen. Can you recall what is oxygen atomic weight? 16, atomic mass 16 AMU, and gram atomic mass 16 grams. Okay, this is the major difference. Please take a note down of this. This is very important. So that's about these three words. Now let us see gram molecular mass also. If molecular mass is mass of one molecule, what is gram molecular mass? It is mass of 1 mole of molecules. Already we have just now completed. Mass of 1 mole of molecules in grams, right? So how do we calculate? Already we know GAM now. In the previous discussion, while calculating molecular mass, we have taken atomic masses, right? Now here, while calculating gram molecular mass, we have to take gram atomic masses. That's it. Let us take the same example as it is. CH4. Now, for as I am calculating gram molecular mass, you have to take carbon GAM, not just atomic mass. How much is it? 12 grams. And for hydrogen 1 gram, so it will be 16 grams. Earlier, and when I asked you molecular mass, we have taken 16 AMU. Here we should take 16 grams. That is the difference. And same I can do for same other example, CO2. Let us say CO2 gram molecular masses. So for carbon it is 12 grams and oxygen it is 16 grams. So 1 into 12, 12, 2 into 16, 32, which will be giving you 44 grams in total. This is what gram molecular mass. I hope you got clarity now. So atomic mass, a gram. So let's come back to the slide again. Atomic weight, atomic mass, gram atomic mass. Similarly, molecular weight and molecular mass. And then gram molecular mass. Okay, so that's what molecular weight is weight of one molecule. Molecular mass is mass of one molecule. Gram molecular mass is mass of 1 mole of molecules in grams. Again, units are same. Molecular weight does not have units. It is having AMU. This is having grams. Let me take example. Let's see H4 only. So here it will be 16 molecular weight, 16 AMU molecular mass, and 16 grams gram molecular mass. This is about the all terminology we have learned. Then ma'am, what is molar mass then? So molar mass is nothing but together GAM and GMM. Together it is called as molar mass. That's it. There is nothing else. This is about the atomic masses, all of this. So it is very important. Before starting this mole concept, actually you have to learn these atomic masses, molecular masses, all of that, so that we can do mole concept in a better way. So that's about the masses and all. So now before going to start mole concept, let me tell you one more topic called atomic mass only. There are two types of atomic masses. You may get question from this. Atomic mass is two types, which is, I say it as shortly, Ram and Arm. What is this Ram and Arm? Ram and Arm is nothing but relative atomic mass. And what is Arm? It is average atomic mass. Average atomic mass. What is this relative atomic mass? Name itself only saying something which is relative. We have to take the value by comparing something. So here we will take one standard element. We'll take one standard element. Earlier it was used to be hydrogen, but after that we used to take C12 as a standard element. I already told you in terms of AMU also. Why only carbon? We have almost 118 elements in the periodic table. Why only carbon as a standard element? Is there any specific things? Yes. The abundance is very much higher. The percentage abundance is very high. That is the reason why we take carbon as a standard element. Next, the other important topic is average atomic mass. So what is average atomic mass? So if you see carbon atomic mass 12 AMU, okay, whatever explanation I gave like protons and neutrons masses, we will add, that's what we get, 12 AMU. But what about elements like chlorine? We'll get 35.5 AMU. From where this 0.5 comes? Either we consider protons and we don't consider protons if it is not there. Like either it will be 5, 6, 7, like that whole numbers only. But protons and neutrons and electrons, it will never be fractions. But from where this fraction came? Is it half proton or half neutron? No, it's not anything like that. It is because of the concept called isotopes. Okay, we'll talk about it. So that's what average atomic mass came into picture, especially whenever there was introduction regarding isotopes. Now let us see what are isotopes. Okay, we all know the element representation X, Z, A. What is X, Nana? X is the element symbol. What is Z? Z is the atomic number. What is A? A is nothing but atomic mass number. So now when I consider isotopes are nothing but, atomic number is nothing but number of protons, atomic mass number is nothing but number of neutrons and protons together. So isotopes are nothing but the elements which have same atomic number, like same number of protons, but different mass number, which is nothing but different A value. That means it should have same Z but different A. Let us take examples. Carbon only, let us take C612, C613, C614. If you observe here in everywhere, atomic numbers are same, mass numbers are different. Similarly, if I take hydrogen, H11, H12, H13. If you see here hydrogen, it is protium, this is called deuterium and tritium. Again atomic numbers are same, mass numbers are different. That's what this is, especially average atomic mass is especially for isotopes, why that fractions are coming. So how to calculate that one? Anyhow, this isotopic masses will be mentioned in the question, you don't need to worry. And also they will mention their percentage abundance. Why we are getting it as average, like fractions and all, because of their, suppose this only will take, Nana, carbon only will take, this will be around 99% it will be existing. I mean, if you take 100 parts of carbon, okay, in that 100 parts, 99 parts will be C12 only. Again in that remaining one part, around 0.8 parts will be C13 and 0.2 parts will be C14. That's what, this is called percentage abundance. Because of this only we are getting the fractions or decimal values. So percentage abundance will be given in the question, this isotopic masses will be given in the question. Based on that we have my formula. I'll explain you that formula now. So let us take an isotope. Anyhow Z is same, that's what, you don't need to specify Z value. So it's isotopic mass. Isotopic mass, take this as A1 and the other isotope mass is A2. If there is 3 isotopes, you can take it as A3 also, that's fine. Either it can have 2 or 3 or 4 isotopes maximum. And then percentage abundances will be mentioned in the question. If one isotope mass is X percentage, you should not take the second one as Y. Anyhow, it will be given, what case I am explaining is, in some cases they will give you average atomic mass, ask you to find percentage abundance. In that case, one you have to take X, the other you should not take it as Y, because we will only have one equation. If there is only one equation, one unknown term we can calculate. That's what we should take it as 100 minus X percentage. Because you keep one thing in mind, sum of all percentages, all atoms percentage abundance should be equal to 100. This is the like information that they can give. What is the formula? Average atomic mass is equal to, the symbol is summation. Summation of isotopic mass into percentage abundance by summation of percentage abundance. Why are we to percentage abundance? Why are we taking summation here. Summation here is expressing that if there is 2 terms, we have to add the other term. If there are 3 terms, we have to add 3 terms, like that. Okay. So let us take this example only. For this example, average atomic mass, first isotope. This is the first, and this is the second. What is the first isotopic mass, Nana? A1. Actually, it will be given in the question, some value. What is its percentage abundance? X. We should not multiply A1 and A2. You should multiply first isotopic mass and its percentage abundance, A1 into X, plus second isotope mass is A2, its percentage abundance is 100 minus X, by sum of percentage abundances, which will be X plus 100 minus X. Anyhow, most of the times the denominator part will be equal to 100 only. Okay, this is what the formula, average atomic mass. So now let us do some 2 questions based on this topic. So the questions are chlorine only. Let us take chlorine exists as Cl35 comma Cl37, and their percentage abundances are 75%, comma 25% respectively. Find average atomic mass. This is the question. Now how to do? So now let us substitute. First you write it like this so that you will get much clarity. Chlorine exists as Cl35 and Cl37, only 2 isotopes. That means what are the isotopic masses? One isotopic mass is 35, other isotopic mass is 37. What is its percentage abundance, Nana? 75, and this one it is 25%. Now average atomic mass. Now come back to the formula. Isotopic summation. There are 2 terms, right? 2 isotopes, right? We have to add 2 terms. So what is the first isotope mass? 35. And what is its percentage abundance? 75. Plus second isotope mass? 37. Its percentage abundance? 25. Divided by sum of percentage abundances, 75 plus 25. So 30, if you observe also 75 plus 25, anyhow it is 100. 35 into 75, it will be 2625, and 37 into 25, it will be 925 by 75 plus 25, 100. 2625 plus 95, how much, Nana? 3550 by 100. 0 will get cancelled. 355 by 10 means 35.5. That is the reason why we get 0.5 for chlorine, right? So this is the reason why we get decimal places for few of the elements. Okay, this is about average atomic mass. Let us solve one more question. Like now in this case, they will give you average atomic mass directly. They are asking you to find the percentage abundance. Let me write the question. Boron exists as B10 comma B11, and its AAM is 10.8 AMU. Find their percentage abundance. This is the question. Now the answer, right? First you write what is given like this so that you will get much clarity. So boron exists as B10 and then B11. So they did not give percentage abundance. That is what we have to calculate. What did I said? You have to take them as X. If one is X, should we take other one as Y? No. If you take like that, if there are 2 unknown terms, we need 2 equations, but we have only 1 equation, kada? So that's what we have to take, 100 minus X percentage. Now average atomic mass is equal to isotopic mass into its percentage abundance X. Average atomic mass also given in the question, right? How much is average atomic mass of this question? 10.8. You take that value only. Is equal to 10 into X plus second isotope mass, how much, Nana? 11 into 100 minus X by sum of the percentage abundances. It will be x plus 100 minus x. X minus x will be getting cancelled. If this 100 go this side, 10.8 into 100 how much? 1080 is equal to 10 into x is 10x, 11 into 100, 1100 minus 11 into x, 11x. Now 10x minus 11x minus x is equal to 1100 goes that side, 1080 minus 1100 minus 20, minus minus will get cancelled. Finally x will be getting 20. What we have imagined x, is it B10 or B11? That also matters because they can ask you the ratio of B10 and B11 or B11 and B10. You should be very careful. So x I have taken B10. So B10 percentage is 20 percentage. B11 how much? B11 it will be 80 percentage. So if they ask you B10 is to B11 ratio, it will be 20 is to 80, which will be 1 is to 4. Same question, but if they change the question at the ending, that's what you have to check, especially when they are asking ratios, whether they are asking B10 comma B11 or B11 comma B10. It will be 80 is to 20, it will be 4 is to 1, because in the options it will be like 1 is to 4, 4 is to 1, 1 is to 2, 2 is to 1, something like that. So this is about average atomic mass. So I hope you got clarity on atomic mass, molecular mass, gram atomic mass, gram molecular mass, molar mass, all of that. So we will be starting mole concept in the next class. Thank you.